So model of a system is a hypothetical abstraction which is simplified to enable analysis of some parts of the system without going in too much details or without the complexity and details of the entire system being analyzed. So this is how we define a model. The model could be a functional model or a security model, right? We are interested in security model because we are studying security architecture and engineering. So in security model, we can define model either formally or informally. So when we define an informal model is just a sketch or a high-level block diagram which shows how the security is being achieved using different components. But when we are going for a formal definition of model, we are interested in formulating a mathematical foundation which can explain the relationship between subjects, objects, and related operations. So we will be investigating here in this video the formal security model of a system, and we will explore some of the key components of the mathematical concepts, and we will see how Bell-LaPadula model is designed around this. So we'll be discussing the mathematical foundation of Bell-LaPadula model, and that is kind of same thing when we discuss other models, but we will not go in too much detail in the mathematical foundation of every security model. I will take Bell-LaPadula model because this is one of the typical security models where if I explain the mathematical foundation, it will give the idea how mathematics is being used in security modeling. Welcome to this episode of Security Architecture Engineering, which is Domain 3, and let's dig in deep detail the topic which I am going to present today. One of the important thing which you should keep in mind, a kind of concept, is that if you see the system, the complete system as a big ball, it has got three layers, right? So the core of the system design is the model, right? And based on the model, we define some architecture, and architecture is further developed into a specific design. So you have got model, security model, right? See, this model is either formal or informal. Formal model means we have got some mathematical foundation, some reasoning and logic which is based on mathematical truth, and then based on this model we define certain architecture. Architecture is concerned with having a balance between the security and functionality of the system, and then we have design. Design is the real engineering, how we can achieve the objective of a specific architecture, keeping in consideration the security model. So there are two related concepts which we should know. One is called finite state machine and another is called the lattice structure. So we should know as an overview what these things mean. So finite state machine says that any machine or a computer system can be in some finite states, right? In a very general example, I can say that if there is a computer, if the computer is switched off, this is one of the state. Then the computer boots with its OS operating system programs running, so that's another state. Then you have a specific application program which is running on the operating system, so this is a third state. There could be a state where a system is compromised or system is hacked, that's another state. So these are different finite states a machine can have. And how these states are identified? These states are identified with the interaction between subjects and objects. A subject can be a real user or a program. An object could be a file system or a program or any information which is being accessed in the system, right? So we have got subjects, we have got objects, and we have got defined relationship between subjects and objects. So these three components define the state of the system. So finite state machine is basically a set of states a machine can have in its normal operation, right? So that's finite state machine. Now lattice structure, what is lattice structure? When we say lattice, we should think of layers, right? So lattice means layers. So the term lattice, we have got this idea of lattice when we were in school studying inorganic chemistry. There we have the lattice structure and the crystals and all those things. Here lattice means a different thing. So the lattice is basically, by definition, it is called a finite set with partial ordering, right? So we have got some terms here, finite set with partial ordering, right? We have to understand what is meant by finite set and what is meant by partial ordering. We all know what is set. A set is a collection of discrete objects which can be well defined, right? So 1, 2, 3, 4, 5, 6. So these are 6 numbers. We can have a set of these 6 numbers, or we can have a set of all even numbers below 100. That's a set of all prime numbers below 200. That could be a set, right? So these are the sets. Now these sets, if they exhibit a property of partial ordering, the property of partial ordering is a concept in discrete mathematics where we have got certain attributes associated with the elements of a set. If these attributes are true, then we say that the set is a partial order. I will come to that. But as a definition, you should know that a lattice is a set of defined discrete objects with partial ordering. So when we talk of lattice security model, the lattice security model is something which uses the concept of partial ordering, right? So there are 4 steps which are being taken in defining a lattice based security model. What are those 4 steps? Step number 1 is that you define a set of security levels, right? A set of security levels you can think of: top secret, secret, confidential, not confidential, for office use only, public. So those kind of levels can be a set of security levels. Now as a stage number 2, what we do, you define a partial ordering of that set. Now this partial ordering is something which is a mathematical concept. I will explain it, but as of now I am explaining how a lattice based security model looks like, right? The first step of lattice based security modeling is defining a set of security levels like confidential, top secret, secret, those kind of things. Then you define a relationship between these security levels, which is called defining a partial ordering of that set, right? What is the set? A set is the collection of security levels here. Now in a third step, what we do, we assign a security level for every subject and every object. So every subject, the subject could be a user or a process, and every object could be any data or any device or any end system which is being accessed. So every system is being assigned to a security level. So we have covered 3 steps. First, defining a set of security levels. It should be defined and it should be finite. It should not be infinite. Second step, we define a relationship or partial ordering relationship between the elements of the set, right? We can say that the relationship is in such a way that top secret is greater than secret and secret is greater than confidential. This is the relationship, right? So define the partial ordering of that set. Step number 3, we have to assign a security level which we define in step number 1 to every subject and object of the system, right? Now step number 4 is about creating a rule where we manually, or the correct term is we discretionally, we define a relationship between a subject and object and how these relationship can exhibit in a normal operation. The operations could be read, write, append, execute. So these are the 4 relationship we will be discussing when we will discuss the Bell-LaPadula research paper. But this relationship has to be defined in a matrix, which is also called access matrix at some times. So this is the 4th step. If these 4 steps are met, we can say that the security model developed is a lattice based security model, right? So we saw that in lattice based security model, our first step is to define a set of security level. What is a set? We all know that a set is a collection of finite objects. Now here in security modeling, these finite elements or finite objects are what? Are the security levels. We can define them based on the type of organization we are dealing with. For government organization, it could be like top secret, secret, confidential, private, those kind of thing. For further details on this subject, you can refer my video which is in domain 2, I think, where I discussed the classification level of assets in asset security, domain 2. Now we have a set, right? So we know what is a set. Now there is a concept of relation, right, which gives rise to function. So if we have a set S, then we define something which is called a relationship R, right? Now a relationship R on set S is called partial ordering if it meets 3 attribute or 3 criteria. What are these 3 criteria? The first criteria is that the relationship between the elements of the set should be reflexive. Second criteria is that the relationship should be antisymmetric, and third criteria is that relationship should be transitive. So these are the 3 criteria. Now whenever it comes to lattice based security model, the concept you should carry is that you have a finite set of security levels first. Second, these elements which are present in the set of that security model follow partial ordering, right? So this set is a partially ordered set, right? In mathematics, this is also called poset. So poset is the short form of partially ordered set. And what is a partially ordered set? I explained that a partially ordered set is a set in which the elements in the set follow 3 criteria or 3 principles, which is they should be reflexive, they should be antisymmetric, and they should be transitive. So if the elements have these criteria, then they are called partially ordered set. So what is partial means here, right? The partial means, the word partial here in partial ordering means that not every elements in the set is comparable. You can define relationship between the elements if they are comparable, right? If they are not comparable, you can't define a relationship. If you have just random elements and there is no relationship, then you can't say that these elements are comparable, right? Formally, the elements A and B of a partially ordered set poset SR, so set S is called set is called S and the relationship is R. So we say that the elements A and B of a partially ordered set poset SR is called comparable if either A is related to B or B is related to A. If this kind of relationship happens, that any 2 elements can be related, either A is related to B or B is related to A, we say that they are comparable. Now incomparable here in this context means that neither A is related to B or B is related to A, right? So it means that in partially ordered set we can make a conclusion that not every set is comparable. Some sets are comparable and some sets are not comparable. We will know what it means in really if we dig down the research paper which Bell-LaPadula actually published in 1976. But as a takeaway, like if you want to know the summary of the material, you can have this understanding in your mind that this set is a partially ordered set which we define in the lattice, and partially ordered means that not every element is comparable. Some are comparable, some are not comparable. That is the meaning of the word partial in partially ordered set, poset, right? And these elements are having 3 properties. One is reflexive, one is antisymmetric, and another is transitive. Now let me give you a demonstration, a kind of example so that you can understand this. Now in step 1, if you see my drawing board, we define a set with security levels. These security levels are here, like S equals to TSCP, where T is top secret, S is secret, C is confidential, P is public, right? So this is the step number 1, we define the security levels. Now in step number 2, we define a partial ordering of the set, right? This means we have to define a relationship among the elements of the set, right? Partially ordering means we are defining a relationship. As I said, in partially ordered set, you have got elements, and some elements are related, some elements are not related. So the relationship you have to establish between elements. If none of the elements are related, it means the set is not partially ordered. But you can imagine, like if you have a relationship, if you have a set with top secret, secret, confidential, private, for office use only, and public, you know that there is a default relationship which exists, like the top secret is more secret than secret, right? Is having more sensitivity than secret, and secret is having more sensitivity than confidential. So a default relationship exists, right? Now, when we say that we have to define a relationship, it means that this relationship should exhibit 3 qualities, that it should be reflexive, it should be antisymmetric, and it should be transitive. This is where the formulation of Bell-LaPadula model or Biba model is discussed. And if you don't know the mathematical interpretation or logic of these terms, it is different for you to arrive at a relationship function R. So this is how a lattice is defined. I hope this is clear, that what a lattice is, and what is a partially ordered set, and how it helps in security modeling, right? Can I recap this whole thing? Let me try. So we defined a model. Like, model is a hypothetical abstraction of a system which is used to study some part of the system without going in too many details of the whole system. The modeling can be done formally and informally. The informal modeling can help in some subjective interpretation of the system, whereas in formal modeling is mathematical and it's objective, and it can help in programming the logic in the computer chips as well, right? So this is the formal definition of security model, right? Now, in security models, we discuss with two things. We discuss finite state machine and lattice. Lattice is a set of security states with partial ordering, where we define subjects and objects, and we assign the security levels to that subject and object, and we define a matrix, which is kind of access matrix, what a subject can do with what object, right? This relationship is expressed in that matrix. We'll go in detail in the next video. Now, this relationship between the elements of a set, which we define in the lattice, is called the partially ordered set, right? The partially ordered set has got elements, and there is a relationship between some of the elements, and these relationships are or has to be reflexive, antisymmetric, and transitive, right? So if these things are maintained, it means that the set is a partially ordered set and it is a part of lattice-based security model. Now, before I jump into the next video, I think I haven't explained what is meant by reflexive, what is meant by antisymmetric, and what is meant by transitive. So in mathematics, if you have a set, like, and the set is having some elements, like let's say 50 or 20 elements. Now, the term reflexive means that if we define a relationship between elements, right? Let's say there are two elements, A and B, and we define a relationship between A and B. Then this relationship should hold true with that element itself as well. So if I say that, okay, we have got a set of 10 numbers wherein the number A divides number B, right? So this is a relationship that A is divisible by B, and you have got the set of numbers. So by the term reflexive means that the relationship, which is A should divide by B, should hold for A and should hold for B as well. So A should divide by A itself as well, and B should divide B itself as well, and that will hold true. It means that the set is reflexive. So if a set is 1, 2, 3, 4, 5, and you have a relationship between that A should divide B, it means that it means that 1 should be divisible by 1, 2 should be divisible by 2, 3 should be divisible by 3, which is true. So this set is reflexive. If it doesn't make sense, I will say that in general life it is a call of hypocrisy check, right? If I am saying that I am honest, right? Or if I say that in this family every person is honest, so honesty is a relationship. Now this honesty should be part of each and every member of the family, right? If it is not, it means that the honesty relationship is not reflexive, right? One example I can give you from politics is that when we say that let's take an example of Indian politics, right? We say that there should not be any black money, right? The government is hunting down the black money, right? There should not be any transaction where we have no details of where the money is coming from, where the money is going. If we have such a relationship, that money is called black money, right? So if the parliament and the prime minister and the MLAs and MPs are standing with this principle of not entertaining black money, right? Then if you have a situation where the political party who is ruling the government is taking the electoral bonds or taking the money from different organizations and they are not explaining from where they are getting the money, it means that there is a difference, right? The relationship defined in a set of MLAs and MP in the parliament is that they don't stand with black money, but they themselves are taking money which is not white, right? They are not disclosing the source of money. Can we say that it's a reflexive relationship? No, it's not a reflexive relationship, because because the entity or the elements of the set are not holding up with the principle they are defining, right? So this is one way to explain. The other thing is antisymmetric. Antisymmetric means that if A is related with B and B is related with A, it means that A and B are same, right? If a person is found doing corrupt practice and a corrupt practice has got, or if a person has got has analyzed a corrupt practice and found that that person is part, it means that the person himself is a corrupt person. I hope this makes sense, right? So if A is related with B and B is related with A, it means that A and B are same. In information security, if you can say that if a subject A is assigned with confidential category and the confidential category is defining the subject A, it means that A and A are same. So this is a kind of logic is used when we talk antisymmetric. And transitive means that it's if you recall your thermodynamics, right? You know, if there are three objects, object A is in thermal equilibrium with B and B is in thermal equilibrium with C, it means that A and C are having same temperature, right? It's the same concept here. If A is related with B and B is related with C, it means we can say that A and C are same. So these are the three terms. Reflexive means that the relationship which we defined on the elements in the set should hold true for each and every element. This is first relationship. Transitive means, antisymmetric means that if A is related with B and B is related with A, it means that A and B are same thing. Transitive means if A is related with B and B is related with C, it means that A and C are same thing. So if we know finite state machine, if we understand lattice based security model, and we know partial order set and these three properties, I think we are ready to understand Bell-LaPadula model in next video. Stay tuned, see you in the next video, and best of luck for CISSP exam.